I made this panel sled to cut pieces of plywood that were larger than what I could comfortably do on a cross-cut sled. And then I was making a queen-size bed, and I found it very helpful to cut the tenons on the ends of the long sideboards of the bed. And then I was making a mailbox with a whole lot of pocket holes, and that required a lot of dados, and I found it very handy to cut those dados and to get all the dados lined up. So I'll show you how I made the sled, and then I'll show how I used it on those projects. I cut this runner to fit just snug in the track. The runner is made of ash, which has a pretty low coefficient of expansion with changes in humidity. And I've got the rings of the tree running vertically here, which will give me the radial expansion, which is lower than the tangential expansion. So what I'm aiming for is very minimal change in width here with seasonal humidity. The way I set this fence precisely in order to get that perfect width was by using a dial indicator here, and then I can tap the fence and move it a thousandths of an inch at a time. And I did tests on pieces of wood as I did that until I got the exact right width, and then I put in my good piece of wood. It's just loose enough that I can push it back and forth with one finger, but it takes a little bit of effort. And underneath I've got a piece of cardboard about a 1/16 of an inch thick to bring it up flush to the surface of the table. I've got a strip of clear packing tape over that. Then I'll cut away the part that is over the wood. Then peel up the piece that's on the wood. And now I can put glue on the wood and hope that the tape will protect that glue from marking up the table. I don't want to put on too much glue because I don't want it oozing out all over the table saw. And that's just a dead weight. Now I can cut off that little strip and get an edge that is perfectly parallel to the miter gauge. For extra security, I'm putting some threaded bolts through the MDF into the hardwood runner. I'm tapping the holes by putting the tap in a drill bit. That's a 22 millimeter long bolt, M5 metric thread, with it just slightly below the surface. Doesn't quite protrude through the bottom of that, so ideal length. I used 1/4 20 threaded inserts here to attach the clamps, and that makes it easy to remove if it's ever in the way. So I've secured one end of the fence with a screw from the bottom through the MDF into the fence, and the other end is loose. So I'll adjust this end until I get things perfectly square. As a start point, I'll just use this framing square. And then I'll clamp the other end over here. And I found that this kind of clamp, although it's very handy, often when I clamp it down it'll shift the piece a little bit. So I go with these C-clamps. I find that better. And I'll put another one in the middle here just in case there's any flexing. The force on this clamp is set by adjusting this screw, and it doesn't depend on the position of the clamp here. So I've set it for a fairly light force because I don't want the fence to be deflected by the clamp pushing down. And really the only purpose of this is to ensure the material is against the table. I can focus on other parts of the material, keeping it in place with my hands safely. When I'm cutting a big piece of material, the sled has to be pulled quite far back off the table saw in order to clear the blade, and that makes it tippy. So this clip-on infeed support stops it from tipping. I'll put a link below on how to make one of those. To keep this edge from drooping and maybe tipping the sled, I can slip a piece of 1/2 inch MDF, same thickness as the sled, under here. To check that the cut is square, I'll use the so-called 5-cut method. This will be my first cut, the one I just did, so I'm going to mark that. Then the piece gets rotated so that that cut edge is against the fence. Oh, and by the way, this fence has a bevel under there so that if there's a little bit of sawdust, it doesn't throw off the alignment. I'll trim a bit off here, that'll be my second cut. Now the second cut edge is against the fence. I'll do the third cut. Now the third cut edge is against the fence for the fourth cut. For the fifth cut, I'm back to where the first cut was. That line reminds me. And I'm going to make it thicker so that I get a little strip that comes off. And the end of that strip that was near the fence I'll mark with an F. If this fence was perfectly square to the blade, then every one of the cuts would produce a perfect 90-degree corner, and this final strip would have the same thickness at both ends. So I'll measure that with calipers and see what we got. And the other end is slightly different. And I'm writing those numbers directly on the piece of wood. So now I can calculate the amount by which this end of the fence has to move in order to bring the fence into perpendicularity with the blade. One end of the stick is 0.360. Subtract the other end, which is 0.326. That gives me 0.034. Now that error is 4 times greater than the actual error, because I made 4 cuts and kept rotating the piece of material, so that magnified the error. Therefore I'll divide by 4. The length of this stick is 23 3/4 inches, so I'll divide by 23 3/4, and that gives me the error per inch. The length of the fence from this clamp to the pivot screw in here is 45 inches. And since this number is the error per inch on the piece of strip we cut off, I'll multiply that error per inch by the 45 inches length of the fence, and that tells me that the fence is off by 16 thousandths of an inch, 0.016. So I'll move one end of the fence by that amount. Because this end of the stick is thicker than the end that was at the fence, that tells me that this piece of wood was tilted too much this way in order to cut off a thick piece. Therefore the fence is too much this way. Therefore the amount I need to move the fence has to be coming back this way. Now I do confess that I find this logic confusing, so sometimes I get it wrong, and if I get it wrong I just go back the other way. One way to move this fence by 16 thousandths of an inch would be to clamp a block on here, then loosen this clamp and stick a shim between the block and the fence of 16 thou thickness, and then tighten up the clamp again. Another way that I think is more accurate is to use a dial indicator if you have one, and I'll preload that by pushing it in, halfway. And now I can set that to 0, and I'm going to take off both clamps, that's important, and then move this away by the 16 thou. And that takes a little bit of nudging, because as I tighten the clamp it changes the reading a little. I'm being more precise than I need to be, I know that. Okay, 16 right on. I'll put the middle clamp on and make sure it doesn't move it. We have to redo the 5-cut method to verify it's correct. I've got my pencil mark where the first cut is going to be. And by the way, I found that paste wax on here made for smoother running than that piece of tape. And I can see by this mark that I'm back to my first cut, so that means I'm doing my 5th cut, and I'll take a wider strip there that I can measure. So at the fence end I get 0.342, and at the other end 0.34, and that's as good as you're going to get. I'll do the calculation just for fun. 0.342 at one end minus 0.340 at the other end, divide by 4. Divide that by the length of this stick to get the error per inch. And the length of this stick is now 23.5. Then multiply that by the 45-inch length of the fence, 1/1000th of an inch error. So over the entire length of this fence, there is 1/1000th of an inch error, so it's essentially perfect. Now just in case I made some mental or calculation error in the 5-cut method, I'll check the diagonals and I find that they are exactly the same as accurately as I can read the tape measure. And another thing to check if we have an accurate square is that the corners are square, which they are. And in fact, this piece of wood is probably the most accurate square thing I have in the workshop. So in a sense, I can use the piece of wood that I've run over the sled as a check to make sure my squares are good. I've flipped the sled over, keeping the clamps in place. Now I'll put in screws from the bottom, and I'm adding a clamp beside a screw before I drill it and put it in. That's so that there's no movement of the fence. And I got the screws just slightly below the surface so they don't scratch the table. Down at this end where the clamp is, there's the pivot screw. And then I put 3 screws along here because as the clamp is clamped down, it tends to pull the fence this way. That's the way the force would want to take it. So these will stop that from happening. So I've removed the C-clamps. This fence is held in place by the screws. The dial indicator is still showing the same reading. So that tells me the fence didn't get jostled or anything as I was flipping it upside down and putting it together. So we can remove that now. The instructions will explain how to install this Craig system with the measuring tape. But very briefly, what I've done is I got a 12-inch ruler, a good one, that I know is 12 inches long. Then I've got that set so that it hits the stop when the other end is just at the edge of the cut line. Then I've got the little magnifying thing with the red line inserted kind of at the midpoint, so the screw hits the midpoint of that. Then I've made a pencil mark on the wooden fence. Then I've cut the backing material just at the 12-inch mark, and I'll lay it down so that it lines up with the pencil line. And then from there I can remove the backing and put the rest of the ruler down. At this end I'll cut the tape at 4.5 inches, and that'll be the minimum width of piece that I can measure using this system, which I probably never would go that small. And it's best to just remove the backing as you go. If you take it all off at once, the thing will be sticking everywhere you don't want it to go. My actual maximum measurable range is just a little over 48 inches, which is kind of a nice number. It doesn't mean I can't cut bigger pieces by flipping the stop up, and then I can do final fine-tuning by loosening this screw, sliding the magnifier to an exact position that I know the fence is set from the edge, and then gently locking it in place. And I'll confirm that by cutting a piece of wood and measuring it and see if I get exactly the number that the cursor is set at. And if not, I can make a further adjustment. This knob has to be tightened down pretty good, otherwise it'll wiggle. And I got tired of doing that, so I replaced them with these comfortable knobs that can be tightened without effort. They've got a Rampa threaded insert with the same thread, 1/4 20, a piece of copper pipe, and turned on the lathe. This stick-on ruler is very accurate when I check it against a stainless steel ruler. Magnifying hairline markers are good for lining up, but one thing that's really annoying is when you get to the 1 foot marks, they put this big black ink on here. And so if you're trying to hit a number in there, it gets very hard to read. Now lots of people make the 1/2-inch tapes. Starrett makes one, and I'm sure they're all equally accurate. They're made of metal. And because there's no fences at the other end, I can go as far as I want this way in material, and I can go as far as I want left and right in material. So it's very versatile in that regard. I think I like this style of toggle clamp better than this approach. It just feels more natural and also gives a handle that I can push on and keep my hand well away from the blade. Here's a piece of panel 30-inch by 60-inch, half of a 5x5 Baltic birch, and I'm supporting on one side by the clip-on infeed table and beyond the table by the Black & Decker workmate with the board. This is the side of a queen-size bed. It goes beyond the ruler, and therefore I'm just measuring with a measuring tape and marking and cutting that way. And if I want to cut a bunch to the exact same length, I can clamp on an extension here with a stop block. To cut the tenons with a dado blade, I've got a scrap of wood screwed to the fence. Then I can butt the fence just up to it, do a 0 calibration, then slide the fence over to the depth of the tenon which in my case is 7/8 of an inch. Depth of 7/8 of an inch as desired, and the tenon is square to the side of the board, and it's the same shoulder depth on both sides. With all the edges cleanly mating. And now on the finished product, I've got a very clean fit of the mortise and tenon on 3 boards, which is not easy because if any one board was just a slightly different length, then they wouldn't work out. And I got them all the same length as I showed using the panel sled with a stop. And equally important is the depth of the shoulder that is cut for the tenon has to be the same on every one. And again, that was done with the panel sled and butting the end up against the block on the fence. The panel sled is also good for cross-cutting long pieces of wood, 6 of them that I want to cut to the exact same length to make some shelves. And I'll use the flip stop, first trimming one end, then flipping the flip stop down to trim the other end, so that both ends are trimmed and the length is exactly what I want. This single blade dado had a lot of overhang with the teeth, so I added some shims on the arbor side in order that it wouldn't cut into the MDF base of the sled. That I can walk between the table saw and the workmate, which might seem trivial, but here's a project where I'm cutting 150 dados. I'm using a single blade dado, so I have to run it through twice to get the width I want, so that means I have to push and pull the sled 300 times. So it's good to have the ergonomics and the flexibility to not have to bend over 300 times. Because the dado builds out away from the arbor, it doesn't cut into the MDF base even when it gets quite thick. All the joints on this mail slot box were made with dados, and because the pieces were cut on the sled with the stop block and the dados were cut with the stop block, they all come out the same size, and that makes the whole thing go together easily and square.